Okay, we're continuing our wonderful journey through simultaneous equations with our last method of solving them, and this is called elimination. It's another algebraic method, but it is different to substitution. Now, just a reminder as to what we're doing here. When you're solving simultaneous equations, you've got two lines graphed, and you're trying to find that point where those two lines are meeting. And we've seen calculator and substitution so far. Elimination's a bit different, and we're going to approach the same problem that we did for substitution, but instead we're going to use elimination to do it. Now, I really want to stress, it's not like there's an easy or a hard way to do this. Substitution and elimination are just different, and some are better for different problems. Some are easier with substitution, some are easier with elimination. So let's see how this works. Basically, with elimination, you're going to add or take your two equations from each other to eliminate either x or y. Sounds a bit weird, but you'll see what I mean in a sec. So first thing we want to do with this equation is we want to write it in the same format. So I'm going to write this with my x's first, so minus 2x plus y equals 1. That top one would become. And the bottom one should stay the same, 2x plus 2y equals 8. Now I'm hoping you can see this has helped us line up. So x's go down there, y's go down there, and numbers just on their own go on the end there. So this is the idea, you always want to write it like that. Okay, so this is still called equation 1. And this is still called equation 2. And basically what I'm going to do is add these equations together. So this is going to be 1 plus 2. So let's see what we get. Minus 2x, add on 2x. Well, that's just going to cancel out. So I get, well, nothing. Plus. Now, y and then I add on another 2y is going to give me 3y. Equals, and let's see, 1 plus 8 is going to give me 9. So in other words, 3y equals 9. Great. So let's see. Now I've got 3y equals 9. I can just divide out by 3 to get y on its own. 9 divided by 3 is 3. We're very happy with that. Okay, so we haven't solved the equation yet. We still need x. So getting x. So you just pick another equation and sub it in. So any one of these two equations. Let's go for 2x plus 2y equals 8, just to mix it up a bit. Doesn't really matter which one. So I'm going to get 2x plus 2 and y was 3, so times 3 equals 8. So that becomes 2x plus 6 equals 8. And then let's see, that becomes, so we're going to take 6 from both sides. Take 6, just like that. That'll get rid of the 6's here. And then we got 2x, well, what's 8 take 6? That's 2. Divide out by 2 on both sides. I'm going to get the 2's cancelling off, kind of. On the right hand side, we're going to get 1. So x just equals 1. So my solution is 1, 3, which I believe should have been the same solution that I got before. And if you graph this on Desmos, you will see that as well. Okay, so that's great, and that's elimination. A lot of people, when I show them elimination, they go, oh, wow, that's way easier than substitution. It is when I show you, but actually spotting what you need to do with the two equations is the hard bit. So you might not immediately see that you do equation 1 plus equation 2. Now, here's an example of where elimination gets a bit spicy. You can see no matter what I do, these aren't going to cancel out with each other. So if I add them there, I'll get 6x. And if I take them, I'll get, what, 2x. Same with y's. They can't cancel out. So what I need to do is I need to basically multiply one of the equations by something to make the number the same in front of the x or the y. And what I'm going to do is I'm going to make the x's the same. So I'm going to leave that top equation as is. 4x plus 7y equals 9. We're happy with that one. And then I'm going to do 2 lots of equation 2 on the bottom. So that becomes 2x. When I double that, I get 4x. And then when I double that, I get 4y. And when I double 3, I get 6. And now I've got 4x and 4x. I'm going to subtract these from each other because then that should get rid of my x's. So 1, take 2, lots of equation 2, and let's see what we get. 4x take 4x gives us nothing. 7y take 4y gives me 3y. And 9 take 6 gives me 3. So I get 3y equals 3. Now, if I divide out by 3 to get my final answer, that's going to give me y equals 1. Let's find our x value. So I'm just going to pick a random equation and sub it in. That bottom one looks kind of nice. 2x plus 2y equals 3 is the equation I'm looking at. And I already know that y is 1. So let's put that in and see what happens. So I get 2x plus 2 equals 3. We want to take away 2 from both sides. So I'm going to get 2x equals 1. So the 2's cancel off, that's 1, and then 3 take 2 is 1. Now I'm going to divide out by 2. The 2's will cancel off there, and I'm going to get x equals a half, or x equals 0.5. So my final answer is 0.5 as my x value, and 1 as my y value. So that's an example of elimination where you have to kind of do some shenanigans with the x coefficients or the y coefficients to make sure they're the same number. So in that case, that same number was 4. Once you have them being the same number, you can then add or take your equations to cancel them off.